Hello, sir. My name is Pradeep Kumar LH, and I'm from Team 17. My teammate is GV Mahesh. Today, we are going to demonstrate our CPS project, which is titled CPS for Smart Traffic Light Monitoring System. The aim of the project is to intelligently control traffic lights based on real-time vehicle density and emergency detection while maintaining fairness using the CPS logic. The problem we are solving at the moment is generally the static traffic signals will waste some time. So some lanes stay red even when they are empty, and high density lanes get blocked longer. We also need a system that provides us an immediate priority to the ambulances or police vehicles, or to be generic, which provides immediate priority to the emergency situations. So we have incorporated all these, and we have developed our project. Our project follows a CPS pipeline, which includes at first the perception layer. Initially, we have to provide the video of the real-time traffic. So at first, we thought of integrating the CPS ESP32 camera so that we can capture the live video of traffic. But the resolution of ESP32 is very low, like it is around 2 MB. So we faced some issues with the YOLO model not able to recognize the video and then count the number of vehicles. So instead, what we thought is, let us give video input to the YOLO model so that the model can count the number of vehicles, and then uh, it can drive the Arduino. So at first, there is a perception layer. The YOLO V8 model processes the video feeds and counts the number of vehicles in that video for 4 lanes in a junction. For example, we'll have north, east, south, and west. We have four different video inputs. So the YOLO V8 processes those video inputs of all lanes and counts the number of vehicles in all of the lanes. And then comes the computation layer, where there is a custom CPS scheduler which decides which lane should receive green. And that decision is based on three factors. One is the vehicle density, and then is the waiting time. And the third one is called fairness constraint. What happens is, even though some lane, if some lane is having very less vehicle density, like one or two vehicles, they won't get a chance to move. All other lanes which are having higher vehicle density will be continuously given green one by one. So in order to mitigate this limitation, we decided to give a fairness scheduling time even for lanes which are having low vehicle densities. And then comes the actuation layer. Based on the output of computation layer, the actuation layer physically drives the Arduino module and switches the traffic lights based on the input from the computation layer. And then we have a digital twin dashboard where a real-time mirroring of signal state and vehicle density can be done. So the whole system forms a perception layer, computation, and then actuation feedback loop. Now let us look at our Python output. So in running the Python script, so we can observe here, this is the digital twin dashboard where the real-time signal state is being mirrored live. So initially the west lane is selected because there are five number of vehicles there. So this is the highest number of vehicles in a lane. So west is turned on. We can also see the output. So so now it switched from west to north based on the fairness logic. That is, north was waiting for some time, and then it switched to south. Now we can observe there are five vehicles in south, and then it switched to east. So all the lanes are given opportunity based on their waiting time, their vehicle density, and the fairness scheduling as well. So Here we can clearly observe in the video, the switching is happening based on the number of vehicles and waiting time. Now, currently, north is activated and then the south is being activated now. And then in the digital twin dashboard, we can observe uh, the timing for green LED. That is, if the vehicle density is more than 8, we will get 15 seconds. If the vehicle density is low, that is less than 8, we'll get 8 seconds. And then comes the emergency part. So if there is an emergency, so we can trigger the emergency and then the emergency lane is activated. So for example, we have 4 lanes here, north, south, east, and west. So if there is an emergency in east, but currently the south is activated. So if we press the respective button, we'll get the emergency activated. That can be shown clearly. So here we can observe initial lane selected was west because of high density. So now I'm triggering uh, the emergency. So before triggering, I'll check. Okay, the west is activated now. So let us trigger an emergency in east. I'm pressing E. So emergency was triggered for east. So immediately east was given green. That can be observed here. So also in digital twin dashboard, we can observe the mode. Mode is emergency. Current lane is east. So if we want emergency triggered, so now emergency cleared, resuming normal scheduling. If we want emergency to be in north, so emergency triggered for north. And here we can clearly observe north is given green and the emergency mode is activated. Current lane is north. And also we can observe the number of vehicles as well in our module. So we have done a simple LED prototype. We have not done a ready to go module because we do not have ESP32 module. I mean, we have ESP32, but the resolution is very low. Instead of using high resolution cameras, we have done a simple project on this. So now I have triggered emergency for south, that is by clicking S. So south got emergency for 15 seconds and then now it switched to north, that is it switched to normal mode and then now the west lane is getting green time. So now I'll again switch emergency for north and so before switching the emergency mode, we have to minimize this, and here in the dashboard we can switch like so. Earlier emergency was triggered for south and then emergency cleared after 15 seconds and it resumed the normal scheduling. Now I'm switching emergency to east, E. So it is showing emergency triggered for east. Here we can see east lane is getting priority over others. So this is how the smart traffic monitoring system using CPS can be done. The reason why we have used video input is ESP32 cam is having very less resolution. That means we cannot achieve the real-time data using ESP32. We need a high-resolution camera, so that would escalate the costs further. So that is why we have used an video input. And this Python model is sending data to Arduino, and Arduino switches the lane as per the Python's instructions. But what happens is, again, we have a feedback where Arduino board sends feedback to the Python model, like for how many seconds it was turned on, and then what lane is currently switched. So after getting the feedback, the Python makes sure that everything is in order. So this is about our project, sir. So thank you.